This question belongs to engineering mathematics subject and was asked in GATE 1991. And the topic name is linear algebra. So the question states the number of integer triplets ij and k with ij and k greater than equal to 1 and less than equal to 300 such that I plus j plus k is divisible by 3 is. So we have two methods of doing this. I will be telling you both these methods. You can follow any of them. So what the question is asking? The question is telling us we need to find the values of I, j and k such that I plus j plus k is divisible by 3, or we can say I plus j plus k mod 3 equal to 0. Such that we have this constraint over I, j and k. I, j and k is greater than equal to 1 and less than equal to 300. So let us suppose how many values can we have for I and j. First of all, let us think it like this. For I we can have 300 values. For j we can have 300 values. How many pairs of I and j we can have? We can have 300 into 300 pairs of I and j. Like we can have any value 1, 1, 1, 2, 1, 3, 1, 4, 1, 300, 2, 1, 2, 2, 2, 3 up to 300, 3, 1, 3, 2, 3, 3 up to 100. And suppose here 2, 2, the value of I to be 2 and j to be 2 will be considered different than the value. Like we will have something like this now 1, 2, 3, 300. Then we will have 1, 2, 3, 300. So 1 can be mapped to anything and then 2 can be mapped to anything. So which means 1, 2, and let us suppose we have 3 and 3 over here, and 2, 1, 3 would be different as these are triplets. So we will have 300 into 300 combinations for I and j. And for any combination, let us take any combination, I to be 5, j to be 3. So 5 plus 3 is 8. So k can be 1 as 5 plus 3 plus 1, 8 plus 1, 9. 9 mod 3 equals to 0. Or we can have 4, we can have 7, we can have 10. So it is equal to 300 by 3. As we have how many factors, how many numbers from 1 to 300 are divisible by 3? It is equal to 300 by 300. So here we can have 100 combination. And let us suppose any other pair for I to be 5, I to be 2 and j to be 2. Okay, then how many can we have? 4. We can have k to be 2, k to be 5, k to be 8, k to be 9 as 9, 10, 11, 12, 4 plus 9. Wait, to 4 to 6, or we can have 5, 5, 6, 7, 8, 9, or we can have 8, 8, 9, 10, 11, 12, or we can have 11, 11, 12, 13, 14, 15. So here also we will have 100 combination. So for each pair we have 100 combination for each pair, 100 per pair. And we have 300 into 300 pairs. So the number of combinations are 300 into 300 into 100, which is 9 into 10 to the power 6. Let me tell you the second method. For second method, let us suppose we need to find I plus j plus k mod 3 should be equal to 0. Which means either what can be the values of I mod 3, j mod 3 and k mod 3. The sum mod 3 equals to 0 when their modulus sums are equal to 0, which means either we will have 0, 0 and 0 as 0 plus 0 plus 0 is divisible by 3, or we will have, let us suppose we have x mod 3. What can be the value of this? We can have 0, 1 or 2 as x mod n can have numbers from 0 to n minus 1. So x mod 3 can have values from 0, 1, 2, and only those values will come in this answer which have their sum divisible by 3. So we will have 0, 0, 0, or we will have something like 0, 1 or 2, or we can have 0, 2 or 1, we can have 1, 2, 0, we can have 2, 1, 0, we can have 1, 2, 0, we can have 2, 0, 1, we can have 1, 1, 1, and we can have 2, 2, 2. Now you tell me, how many pairs are divisible by 3 such that they give the remainder 0? There are only 100 pairs. There are 1, there are 3, 6, 9 up to 300. And there are 100 pairs. So we have 100 pairs for this. And how many pairs gives the modulus 1? So there are 4, 5, 6, 7, 8, 9, 10. There are also 100 pairs of this, 100 pairs of this, and 100 pairs for this. Like we can have 1, no, mod 3 equal to modulus equals to 2. So we can have numbers like 5, 6, 7, 8, 9, 10, 11. So there are also 100 numbers. For each we have 100 numbers. So a pair will be equal to 100 into 100 into 100 combinations for a pair. And how many pairs do we have? 1, 2, 3, 4, 5, 6, 7, 8, 9. And we have 9 pairs. So the answer is 9 into 10 to the power 6. So both are giving 9 into 10 to the power 6. So the answer is 9 into 10 to the power 6.